All right, last problem set of the year. And let's do purple. So we're looking at transformers. Basically how they will a little bit the equations, then we will show you how they work. So when we look at transformers, we've got there's a relationship that the incoming voltage VI or V1 divided by V2, which is the outgoing voltage, is equal to N1 over N2. And so depending upon how many turns the transformer has in the coils of wire, will bring the voltage up or the voltage down. So if we look at a picture of this, basically we have a piece of metal, and this is a coil wire coming through here and a coil here. And this is these are pieces of metal. And so say we have, we're looking for V1, V2, then 1 and 2. So we're going to look at step up, meaning we're increasing the voltage. So V1 times N2 divided by N1 should equal V2 if we rearrange the equation. And so what happens if we have, say 5 loops, and it's equal to 5 over here, and we have N is equal to 25 on the right. So we plug in, we have a 10 volt coming in. So 10 times 25 divided by 5, and that should give us a step-up voltage of 50 volts. So this means with this transformer, we're actually increasing the voltage across each side of the wire, making it up to about 50 volts off current 5 times. And what happens is that we got more turns here, so the magnetic field is going to affect the voltage in these wires a lot more than it is here. So these are what we call step up. Step down, N2 is going to be less than N1. I'm going to say N2 is greater than N1. So we're going to do it this way. So step down, we've got more wires at the beginning. So in this case, we've got 25 wires here, and we've got 5 wires here. And let's look at it again, what happens when we step it down. So we got 10 volts stepping it down. We have 5 turns of N2, we got 25 on N1, and that's going to equal voltage 2, and that should be less than 10. So 10 divided by 5 is going to give me 2 volts, and so we have basically we're dividing by 5 each time. And it's just this relationship between the voltage and the number of turns on each side of this transformer. Realize a transformer is basically a magnetic field that interacts with these 2 wires. And so, and it's an electromagnet. It's because this is a piece of magnetic metal in here. So we have this field increasing and decreasing based on the AC current going through. The more turns we have, the more it's going to have a higher voltage. That's the way we're going to look at this. And so we're going to step it up or step down. So here's our example. We have an AC generator that produces 1,980 kilowatts of power. That's a lot. And we can say 1 times 10 to the 3rd watts, or 1.38 times 10 to the 6th. Both of these are the same number. We're just converting it so it's something that was more usable. And so, guess what? We don't need this, because what we have is the secondary coil has a potential of 3.4 kilovolts, and it has 17 turns. So N2 is 17. V2 is 3.4 kilovolts, so 3,400 volts. We want V1, and N1 is actually equal to 340. So let's go ahead to the next slide and let's get all this down properly. So the equation V1 over V2 is equal to N1 over N2. N1 is equal to, let's see, what we get, 340. N2 is 17. V1 we don't know, and V2 is 3,400 volts, or 3.4 times 10 to the 3rd kilovolt, 10 to the 3rd volts. So there we go. So let's plug this in. We're looking for V1. So move V2 over, multiply by both sides. So V1, N1, V2 over N2 is equal to V1. And so now we're going to put numbers in. N1 is 340. V2 is 3400. Whoops. Yeah, that's right. N2 was 17. So let's go ahead and do the simple calculation. You guys should be able to do the arithmetic. 340 times 3400. I should turn my calculator on. We divide that by 17. And what we have is the initial power coming out of that station is 68,000 volts. That is a lot of power. That is a lot of that is a tremendous potential difference. Very shocking, actually. Now, we want to know the current in the primary coil. So, power, remember, it's I squared R. V is equal to IR. We're looking for, we know the voltage, IR. So P is equal to I times V. So current times voltage is equal to power. We know the power. That's 1.38 times 10 to the 6 divided by the voltage, which is 68,000. That should give me I, because basically what I'm doing here is P divided by V is equal to I. 0.38 raised to the 6 divided by 68,000. I have a current of 20.3 amps. That's a lot of electrons flowing at that time. Right, this is the end of problem set C for chapter 20 and the end of the unit and the end of the semester. Thank you, folks.